Hi, this is Irv Shapiro of the DrVAX channel, and today we're going to, in essence, do an accidental video. My intention was to produce a video on items you can use to organize your home. So hooks you can use in your closet, little storage containers you can use in your bathroom or your kitchen. And as part of that video, I was going to teach you how to customize and design these items. Because after a while, it gets a bit old just downloading STL files and printing them on your 3D printer. The way to really embrace the creativity of 3D printing, the potential of 3D printing, is to design or customize your own items. One of the tools I was going to use was the Customizer in Thingiverse. But it's broken. And it's unfortunately often broken. In fact, Thingiverse is often broken, which is a great frustration to many of us in the 3D printing community because it's such a wonderful collection of objects for printing, thousands and thousands of objects, and many of us, myself included, have published items on Thingiverse, but it keeps breaking. Now it's clear the folks at MakerBot are trying to fix Thingiverse because they've added ads in order to generate some revenue. Hopefully that revenue will be used to support a development team to make it a better product. But right now, the customizer is broken. And so I had to find another way to produce my video. So today, we're going to learn about the underlying technology called OpenSCAD. OpenSCAD is a programming language you use to design 3D objects. And the Thingiverse Customizer relies on that programming language. Today we're going to learn how to take an object from Thingiverse and using the desktop version of OpenSCAD, which runs on pretty much any computer, we're going to learn how to customize those objects. We're then going to go a bit further and learn a bit about the language of OpenSCAD so you can produce your own customizable objects that you share with other people. So stay tuned and let's learn something together. Okay, folks, before we get started with this video, remember to subscribe to the channel. If you like the video at the end, give me a thumbs up, leave a comment. If you want to discuss all of the videos I talk about and actually upload your own examples, you can go to forum.drvax.com. Now, to begin our journey, let's start at Thingiverse. So let's turn to the screen together. If you look at the screen here, you'll see that Thingiverse lists a variety of objects. You can search for objects by putting the object name or description in the search bar, and search does appear to be working today. That wasn't working a week ago. So this is a website in need of some attention. One of the most powerful features of Thingiverse is under the Explore tab, there's an item called Customizable Things. If I select that item, I'll be taken to thousands of individual items that are designed to be customized. So let's click on this customizable screwdriver holder. Looks like a good idea. And you can see here it looks like a regular Thingiverse page. Now I can click on the side here, Open in Customizer. Open in Customizer will show up for any object in Thingiverse where there's a .scad file. And you'll see here that it will let me define the number of screwdrivers, the number of holes, the width for each one, some extra distance on the ends. Over here on the side, I can see a picture of what it looks like. Now, when it used to work, I was able to easily put in a new value here, hit a tab, oh, and that did work a little bit, and it will show you a revised picture. Let's see if I can move this up. doesn't look like the manipulation tools are working very well. Ideally, I'd be able to manipulate this object here. Now, underlying any object in Thingiverse that has the customize option will be source code. If I click on source code here, you'll see these are the variables. Variables at the top of your SCAD file will show up in that table as a parameter. These are some variables that are hidden. They're not going to show up over there. And then here's the actual code in order to produce that screwdriver holder. So what we're going to do now is I'm going to download this SCAD file, and then I'm going to open it in the desktop version of OpenSCAD. And we're going to see how to use the customizer, because in the desktop version, it's snappy, it's quick, it works easily. So I'm going to go back to the screwdriver page, go to Thing Files, and you'll see here there's an SCAD file. I'm going to click on Download. Now I'm going to go to the OpenSCAD homepage and download the application. I'll provide a link to this in the description below, but it's just OpenSCAD, OpenSCAD.org. And you can see here that it's a programming language for defining three-dimensional models. There's an excellent set of documentation listed here also. But for right now, I'm going to click on Download OpenSCAD. That will download the installation program to my computer. In the case of a Mac, I just click on that. It opens up the distribution. And then I drag this to my application folder. In the case of a Windows machine, it downloads a .exe file, and that you'll have to run in order to do the installation. Okay, now that you've installed OpenSCAD or OpenSCAD, it's time to run the program, and we're going to use it to customize that screwdriver. So I'm going to click on the application. It will display a welcome screen. Now, because I've already opened up the screwdriver model before, that's showing in my list of recent models. But let's assume I hadn't. I could click on Open. I can navigate to that screwdriver file, say Open, and it will open on the screen. Now let's look at the panels on the screen. Over here we have the source code. This is all of the code, and I know this looks scary, but we're going to show you how easy this really is. And if you start with little bits, the code is easy. More importantly, you don't need to look at this at all. So for right now, I'm going to make that very small so we don't see it, because we're going to concentrate here on our model. So I'm going to take the right mouse button and drag it towards the center. Then I'm going to take the scroll button and scroll in so it's smaller. Now, if I wanted to customize this, I need to get access to those parameters. So I'm going to go up here to View, and I'm going to unclick the check mark next to Hide Customizer. And now the custom parameters are available. The number of screwdrivers, well, let's change that as an example to 3 and hit Tab. Just change to 3. See how easy that is? Let's put it back to 5. Let's say the screwdriver width is wider. Let's set an extra distance of 10. And the slot width, I'm not sure what that does. I'm going to set that to 5. Ah, I see. That makes the slot where the screwdriver goes through a little wider. So we're going to put the extra distance back to 1. And now we can see here we are all set. Okay, after setting the parameters the way you want, you can get a rough idea of how this looks. Now, in this view, you'll see things are sort of coming in and out. That's because this is in draft mode. In order to see exactly how it looks, we're going to want to render it. But there's another reason you have to render it. You can only save files as STL files that you're going to use with your 3D printer if you first render them. So we go to Design, render, and that's going to clear the preview and then show us our model in full resolution. So now we can actually see the holes in the back. We can see the slots in the front. So we are ready to print this. How do we print this? Well, we save it as an STL file. We slice it on our favorite slicer, Prusa Slicer, Cura, Simplify 3D, and then we send it to our printer. So let's first save it. To save it, we're going to do an export as STL. And I'm going to actually export that to this directory up here. Now I'm going to open up Cura. Now that Cura has opened, I'm going to open our model. So I saved it over here. And let's go to a list view. Here's our screwdriver holder. Open it up. And interestingly enough, it didn't position in the center, and it's actually a little too big for our printer here. So we're going to have to make this smaller for this Creality Ender 3 printer. So we could scale it here, or I could go back and scale it in my modeling program in OpenSCAD. So let me actually delete this here. Delete selected model. I'm going to go back to here, and clearly this is too big. Now, how do these sizes translate? Because OpenSCAD is what's called a unitless system. That means that you have a unit of 1, 2, 3, 4, or size of 1, 2, 3, 4. It's whatever you want it to be. It's based on your post-processing program. Most slicers will take an STL file unit and by default convert it to millimeters. So let's set the number of screwdrivers here to 3 for our test. And that should make this small enough to fit on our print bed. We'll go to Design, Render. We'll wait for this to render. Now we'll go to File, Export as STL. We'll overwrite the file that's already there. Now we'll go back to Cura. And in Cura, we're going to load this in and see if it'll fit now. Open, screwdriver holder, open, and it fits nicely. And you can see it rendered perfectly in Cura, ready to be printed. Now, let's dig in under the covers a little bit. And instead of just taking a model and manipulating the parameters, let's create our own model. Now, this example script is much too complex, so let's start with some simple ones. So I'm going to open a new file here, and this file is called the DrVAX OpenSCAD examples, and we'll turn off the customizer because we're going to actually look at the code. Now, when we're looking at the code, you'll notice this top line starts with a slash asterisk and ends with a slash asterisk. That's a comment. That means it's not going to impact the actual model. Also, if you want a single line comment, you can just start it with a double slash. So the nice thing about the star asterisk approach is I can have many lines to the comment. So those are comments. Now let's start with something very simple. I want to just create a cube. So I'm going to take the comment off this line. The cube has a width, a depth, and a height. So let me take and preview that cube, and you can see it looks like that. If I change this to 20 and preview it, it's going to get a little taller. That's basically all there is to it. You take various commands, primitives, you define sizes, and you manipulate them. So let's try some other examples. Let's uncomment this sphere with a radius of 20. I'm going to click preview, and there we have a sphere. Now you'll notice on this sphere, in particular if we zoom in, you can see these facets on the sphere. That's the size of the face detail. Well, we can take and we can tell it to use more facets, make the details smaller by defining a variable called fn equals. And so let's make this fn equals 100. Preview again, and you can see how small those got. And if we actually do a full render, you can see it's relatively fine now. We could make this bigger. Preview, render, and now it's really very hard to see those. Now, the reason for that fn variable is that when you were working on slower computers, I'm working on a relatively fast MacBook here, a couple years old. When you were working on slower computers 5, 6, 7 years ago, sometimes it took a long time to render if you made the details used to create the shapes very, very small. But you can see now it works great with very fine detail. Now, another thing we can create is a cylinder with a height of 25, and cylinders have a top radius and a bottom radius. But let's leave them the same for right now. Let's render this, and there's our cylinder. If I make this one 30 and re-render, now the top radius is big and the bottom radius is small, and I've created a funnel. Pretty easy, isn't it? Now, let's turn on center equals true and re-preview this. And now the center of this object is at my center of my coordinate system. If that's false, the object renders in a location relative to the center, but not in the center. So if I make this false, we'll see it moves up. Now, cylinders are very interesting because the $fn parameter can be used to change how many sides. So we saw it with 100 or 200 got very smooth. What the default, let's say, was 20 or 30, was relatively rough. Well, what if we tell it to make a cylinder with just 3 sides? I think that's a triangle. So let's take a look at this example here. And we're going to say the number of sides is 3. Render that. We have a triangle. Now we still can vary the top and the bottom. So I'm going to make the bottom bigger, render it, and now we have a pyramid. Let's make this a little bit higher so we can see it more easily. And now we have a pyramid. And if I now render it instead of being in preview mode, we'll see it much more clearly. So we've covered 3 basic shapes. How do you create more sophisticated objects? Well, you combine shapes together, which is the same thing you do in any CAD program. So the first thing you need to be able to do to combine shapes together is you need to be able to move a shape. The way you move a shape is you do a translate. Translate says reposition this somewhere. So we're going to do a translate that basically resets the origin, the starting point of where it's going to draw. So we're going to do this translate here of a cube, and you'll see now this cube is up above in space. If we change this 10 to a 3 and re-preview, we'll see it moves down. We change it to a 15, we'll see it moves up. So it's as easy as that to position where you're going to draw something. Then everything else you do is the same. So translate is used to draw things. Now let's talk for a second about syntax. The end of an operation in OpenSCAD is a semicolon. So here I do a translate, and then the object ended by a semicolon. That means it's the end of that object. Now, if instead of just moving objects, I potentially want to combine objects together, well, I can do a union. So this is now one object combined together. Now, because the default characteristics of where a sphere is drawn and where a cube are drawn are different, they didn't end up inside of each other. If I say to the cube, if I add a second parameter and I say center equals true and now re-render, you'll see they're now in the same space because I can't actually even see the cube, this sphere anymore. So let me make the sphere a little bigger. Let's make that about 17. Too big, and you can just barely see the corners popping out. We'll make it 15. And now see here how you can see the corners of that cube popping out? Let's make it even a little smaller, 13, and you should be able to see both shapes. So I've combined together those two shapes with a union. Now, if instead of combining together space shapes with a union, I do a difference, I will cut one shape out of another. So that's how I create a hole. So here we have a difference of a cube that's centered and a sphere. I'll preview that. And we create this wonderful looking object with a hole in the middle. Now, using these basic commands, the ability to create objects, to translate objects or move the starting point of the draw. There's another command to rotate objects, union difference, and a couple of other more sophisticated commands. You can basically create anything. So let's start by creating a mug. So I'm going to comment this out, and you'll see here, down here, I have the multi-line comment set. We're going to take that out now. And let's look at what we have here. First, I've defined a couple variables. Because I've defined them up at the top, and there are a set of rules about this that are beyond today's lesson, these will show up in the customizer. Now I'm going to create a cylinder. Then I'm going to move another cylinder up a little bit because we want to have a base on our cup. So I'm going to take another cylinder and put it inside and subtract it from that first cylinder. So the difference command will subtract the second object from the first object. Let's actually comment out the rest of this down here so we can just do that. So I have a height and a radius and one cylinder and a second one that's cut out of it. So let's render this. And if we bring this into view, we can see we have a cup. Now, because we have these variables at the top, if I turn back on the customizer, I take off the hide customizer, we'll see we could change those variables right here now. So I can make this 90, tab, and that just got smaller. I could make this 180, tab, it just got bigger. So that's how Thingiverse interacts with your SCAD file. There are some specific features you can use here. If I put this in square brackets, it will label it as a tab. So you can see here it now says mug size and now height and radius. And there's some other features you use with setting up the customizer. We're not going to cover those today. Let's continue to build out our model though. Let's take out this comment here and this comment here. And now we created the cylinder, and now let's create the handle. Well, the handle is basically one circle, one cylinder, another cylinder inside, and then it's overlapping with the cup. So we define the overlap with the cup with this radius command here. So let's render this here. And now you'll see we have a handle. Now, if I took and I changed this, let's say I said this was 0 and re-rendered, you'll see the handle now is down in the wrong position. So I used the height variable to say where the center, where my origin starts, when I'm going to start rendering or creating that circle. Now there's a problem with this cup, however. It looks very beautiful from here. And in fact, we could render it in higher resolution. Very nice. The handle is inside. Well, why is that happening? Well, let's look at the order. First, we're creating a cylinder, then we're cutting a cylinder out of the inside. Then we're creating the handle. We're positioning it so it's overlapping with the cylinder, but we didn't cut it out from the inside. So we could add another operation to cut it out from the inside, or a better way to do this is to restructure this script a little bit. And this is a little more complicated, but it'll give you an idea of how this all works. So now we have this one here, this example here, and we'll walk through it. Let's first render it. Whoops. Line 51. Aha. There we go. Okay, we fixed that. Now let's render this. And now, if we look at this cup, we'll see that the handle is not piercing the cup. It's just on the outside. How do we do that? Well, this time we did the cutout of the inside after we assembled the whole mug. So the way we did that is, let's actually take right now, and I'm going to comment out a difference, and I'm going to comment out the hole in the mug, and we'll see here we create a cylinder, then we create our handle. Let me move this over so you can see this a little better. And the handle still has the two parts, has the outside of the handle and then cutting out the inside. We're doing a difference from the outside, we're cutting out the inside. We've positioned the proper places. Let's render this, and you'll see here we have a solid cup. Now I want to take this solid cup and I want to cut out a hole from it. Well, difference takes two parameters. So how do I do that? Well, I combine together the mug and the handle using a union option. So you build up pieces, you unionize them together, and then you can further combine them. So you can do a union of two unions. You can do a difference of two unions. You can do a union of two differences. So now we have this union, which is the mug and the handle, and then this translated object, shifted object, which is the cylinder inside, we're going to cut out. So now you can see this works perfectly. So now let's render this at high resolution. We'll do a file, export as STL. And we're going to call this DrVAX mug. Save. Let's quickly go ahead into Cura. Now let's open up our DrVAX mug. Perfect. Perfect. Now see the red here on the inside of the handle and the bottom of the handle? That says that this might need supports to print properly. So this particular handle shape might be a little hard to print. But we could try it, or we could print it with supports, and it would put some supports in there automatically if we select that option in Cura. Okay, folks, I hope you learned something today. I hope you enjoyed this. Two things. Number one, you can ignore all the programming stuff if it's not your thing. Just download OpenSCADs, download a model from Thingiverse, open it up, make sure you uncheck the Hide Customizer panel option, and you can customize things, render them, save them, you're all set to print. But if you found the programming interesting, hopefully I've opened up a new concept for you, and you can make your own models suitable to upload to Thingiverse and use with the customizer. Thanks so much for watching. I hope you learned a lot. If you like this, give me a thumbs up. If you want to discuss OpenSCAD, go to forum.drvax.com. Join the community of users discussing the DrVAX videos. Have a great day, and let's continue to learn things together.